Good to see you, boys and girls. This is Magical Mathematics with Miss Marla. On today's session, we will be discussing real world applications in the coordinate plane. This is part two of our fifth grade geometry standards as it relates to working in the coordinate plane. I hope you're ready. You may be asking yourself, what supplies do I need? Well, for this lesson, you'll actually only need two things. You'll need a pencil or a marker and a couple of sheets of graph paper. Go ahead and grab those two items and let's get started. Now that you have your materials, let's do a quick review of lesson one. If you remember in lesson one, I introduced you to the coordinate plane. Now remember, the coordinate plane can also be named the coordinate system. We talked about two axes. We talked about the very important place where these two axes intersect. We also spent some time labeling and plotting ordered pairs. We talked about the four quadrants, and the very last thing that we talked about was how each of the quadrants have different characteristics. If you see here on the screen, I have actually given you all of the important things that we talked about during lesson number one. But let's see how much you remember. So taking each of the items that you see here, place them on your coordinate plane using your marker or pencil. Let's see how much you remember. So let's check it out. How did you do? Did you identify your X and Y axes? Did you also identify the origin as that very special point where these two axes intersect? Remember that we labeled the point, the origin, 0, 0. Were you able to identify the point 4, 1 as the point that is 4 units to the right of the origin and 1 unit up? Did you identify the point 1, 5 as 1 unit to the right of the origin and 5 units up? And then finally, how did you do on identifying our four quadrants? If you remember, quadrants 1, 2, 3, and 4 go in a counterclockwise direction. And remember, during lesson one, I gave you a hint. You can always remember the direction in which to label them by drawing the letter C. How did you do? Now we're rocking and rolling, boys and girls. You may be asking yourself, what will I learn today? Well, we're going to take it up a notch, fifth graders. We're going to take everything that you just learned in the first lesson and on your graph paper and apply it to the real world. So let's see what our second standard is. Our second standard reads, represent real world and mathematical problems in the first quadrant of the coordinate plane and interpret coordinate values of points in the context of the situation. That sounds like a lot, but there's some key vocabulary words in this standard that I want you to write down. So remember, anything that's real world means it could happen in the world around us. Remember, everything in the first quadrant is what? That's right, positive, positive. The x coordinate is positive and so is the y coordinate. Now those last two vocabulary terms might be new to you, but let's take it one by one. If I want to interpret something, that means that I have to be able to explain it in words. In addition to that, I'm going to take each point that I plot in the first quadrant and I'm going to talk about it in words as it relates to that real world problem. So it's not going to just represent an X and a Y value, it's actually going to represent something in the real world. So that means our X and our Y could actually represent two different variables. And remember, variables are something that can change. So again, we're going to take those points that we plotted in the first quadrant, apply them to the world around us, and describe it in words. Are you ready? Let's try a fun and easy real world example. Let's pretend that you have four friends, and each one of your friends worked a job that paid them last week. Your four friends are Chris, James, Marla, and Leanne. Now, because each of your friends work a different type of job, they're paid a little different. So for the job that Chris worked, he worked 1 hour and was paid $2 last week. Your friend James worked 8 hours and was paid $4 last week. Can you tell me how many hours Marla worked and how much she earned last week? That's right, Marla worked 4 hours and earned $5. What about Miss Leanne? That's right, Leanne worked 8 hours just like James, but she was paid $10 last week. Now, my question to you is this: what quadrant am I representing this data in? That's right, quadrant 1. And how do I know that? Because both my hours and money are positive numbers. And remember, everything in quadrant 1 is positive, positive. So what do you think would happen if I were to remove the numbers on the x-axis and the numbers that are on the y-axis? Would you still be able to make some types of observations as it relates to how many hours each of your friends worked and the amount of money they earned? Let's see if you're able to do that. All right, let's take it up a notch. What type of observations can you make now that I have completely covered up each of the numbers on the x-axis and on the y-axis as well? You still know that hours worked on the job is represented on the x-axis and the amount of money earned last week is represented on the y-axis. You can still make observations about this relationship for each of your four friends, but I also want you to make a relationship observation as each point is compared to each of the other 3 points around it. So let's make one observation. I would like for you to make the observation between Chris and Marla. Now, as you make that observation, I want you to always think about how do each of these points relate to the origin and each other. So let's talk about it for a moment. Marla is further from the origin as it relates to the x-axis, and she's also higher above the x-axis than Chris is. And so the observation between Chris and Marla is that Marla must have worked more hours on the job and earned a little more money than Chris because her dot is further above the x-axis. Let's make an observation between James and Leanne. And we already talked about this a few moments ago, but let's make that observation now that the actual axes has been covered up. That's right. James and Leanne must have worked the same number of hours on the job. But the fact that James's ordered pair, or his dot, if you will, is closer to the x-axis, that means that he must have earned less than Leanne. You got it, boys and girls. See, you don't need the axes labeled for you to make really good observations. We're going to take this up a notch, and let's see if you can still do it on another real-world problem. Are you ready? All right, boys and girls, let's take it up a notch. What we have here are 7 points represented by 7 different people. What we're representing is how tall each person is, that's their height, and how old they are, which is represented by their age. I'm still talking about real world examples in the first quadrant. The only difference now is the x-axis and the y-axis do not have numbers on them. But you're so smart, boys and girls, you can make really great observations without the axes being labeled. So if you're at home watching me on your television, or you happen to be watching me on your tablet or on your smartphone, I want you to use your finger as we make observations. The first point I want you to place your finger on is the point 7. What type of observation can you make about the person represented by this point? That's right. Whoever's represented by the point 7 must be the shortest, and they also must be what? The youngest. That's right. And I can make that observation because this point is the closest to the origin. Let's make an observation about the point 4 and the point 5. Place your finger on the point 4 and place another finger on the point represented by the number 5. What types of observations can you make about these particular points which represent 2 different people? That's right. Because these points are the exact same distance above the x-axis, that means that whoever is represented by the points 4 and 5 must be the exact same age. You got it, boys and girls. The only difference is whoever is represented by the point 5 must be a little taller. And how do I know that? Remember what we talked about in lesson 1? The further away you are from the origin, as you move away from the origin in the direction of the x-axis, that means that value must be larger. We're in quadrant 1. Keep that in mind. Everything is positive, positive. Let's do another observation. Place your finger on the point 2 and the point 5. What types of observations can you make about these 2 people? That's right. Whoever is represented by the points 2 and 5 must be the exact same height. But what's the difference? You got it. Whoever is represented by the point 2 must be a little bit older. And how did you know that? That's right, because the point 2 is further above the x-axis. Do you remember what we talked about when we were talking about Leanne and James and the amount of hours each of them worked and how much they were paid? Well, points 2 and point 5 work the exact same way. I'm so proud of you, boys and girls. You don't even need the x and the y axis labeled in order to make observations. We're going to take it up one more notch. And what I'm going to do is show you the 7 people that are represented by the 7 dots here. Are you ready? Now comes the fun part. There are 7 people standing on the bus stop. These 7 people represent the 7 points that we just talked about. What I would like for you to do is to take a few seconds and make as many observations as you possibly can. Now, as you make those observations, remember, we're going to be able to represent those 7 people by the 7 dots in relationship to, that's right, their height and their age. Take a few moments and see how many observations you are able to make. Perfect. You should have noted that Alice and Errol are the exact same height. But something that's different about them is that you can definitely see that Alice might be a little bit older than Errol. You got it. What did you notice about Brenda and Dennis? They're also the exact same height. But if I look at Dennis, I can tell that he's a little bit older than Brenda. What do you notice about Kathy? That's right. Kathy looks like her height is unlike anyone else's. And it also looks like no one else is the same age as her. So she's the lone dot. And then we have 2 other people that we need to make great observations of. That's right. You probably didn't see baby Gavin in Frida's hand. Well, what do you know about baby Gavin? That's right. He's the youngest, and because he's a baby, he is absolutely the shortest. So what does that tell you as it relates to the 7 points that we looked at a few moments ago? That's right. If I were going to represent Gavin in relationship to the other 6 people, he would be represented by the point that's closest to the origin. Now, I've mixed these up just a little bit, but let's look back at our graph and see if you're able to match each of the 7 people here with the 7 points represented on our quadrant 1 graph. Now comes the fun part. Let's take everything that we just learned in lesson 1 and add it to everything that we've just learned here in lesson 2. Remember our 7 people that were standing on the bus stop? We've made a lot of observations as it relates to each of those 7 people, their height, and their age. Let's go back and recap what we've talked about so far to see if we can match each person with the point they represent. This is real world data at its finest, boys and girls. Let's see if you remember. So we said that Alice and Errol were the exact same height. We also noticed that Alice was a little bit older looking than Errol. So the question is, how do I know where they are on the coordinate plane? Well, let's think about that for a second. Alice and Errol are the tallest of all of the people on the bus stop. So that means that they are going to be the furthest away from the origin as it relates to the x-axis. They're moving the furthest from the origin in the direction of the x-axis. But Alice is what? She's a little older. Let's keep going. We also said that Brenda and Dennis were the exact same height. But the difference is Dennis looks a little older than Brenda. Do you know which 2 dots they represent? They're the exact same height, but Dennis looks a little older. So that means his dot must be a little further away from the x-axis. He's a little what? Higher above the x-axis. That's right. We also talked about Kathy. Now, no one is the exact same height as Kathy and it doesn't appear that anyone is around the same age as her. Do you know which point Kathy represents? And then we also talked about baby Gavin. Do you remember what we said about baby Gavin? Remember, Gavin is right there in Frida's arm. Now, because he's a baby, that means he's the shortest, and he's also what? That's right, he's also the youngest. So if he's the shortest and he's also the youngest, he must be the closest person to the what? You got it. He's the closest one to the origin. And then just like Kathy, no one else appears to be the same height as Frida. Can you identify which point represents Frida? All right, boys and girls, time to check yourself and see if you are right. Write your answers down and let's see if you matched each person with the correct point. All right, boys and girls, that brings us to our final answers. Did you get them all right? Remember we said that Alice and Errol were the exact same height, but Alice was a little older. Same height, little older, which means Alice's point is much higher above the x-axis, and they're the taller of the group. Brenda is the exact same height as Dennis, but Dennis is a little older, which means what? His point is a little higher above the x-axis. Little Miss Kathy, her height is unlike anyone else's, but she's not as young as baby Gavin. And we already knew that baby Gavin was going to be the closest to the origin. So that means that Kathy is going to be represented by the point 6, and we already knew that Gavin was represented by the point 7. That leaves us with who? Just Miss Frida. Miss Frida, like Kathy, her height is unlike anyone else's. So she's represented by the point 3. Let's make some additional observations. I noticed that what? Point 4 and point 5 are the exact same distance above the x-axis. So that means that Brenda and Errol are the exact same what? That's right, they're the exact same age. Different heights, but they're the exact same age because they're the exact same distance above the x-axis. Now let's make a comparison between Dennis and Alice. Remember, Dennis is represented by the point 1 and Alice is represented by the point 2. Their point is the exact same distance above the x-axis also. So that means that Dennis and Alice are the exact same age. The only difference is Alice is taller than Dennis, which means what? That's right, she's further along the x-axis, away from the origin. How did you do, boys and girls? I hope you had fun as it relates to matching ordered pairs, which are represented by points in the coordinate plane, and matching them with real-world examples. This was fun. That brings us to the end of this lesson and our episode on our 5th grade geometry standard representing real-world problems in the first quadrant and interpreting those coordinate values in the context of the situation they represent. I am so very proud of you, boys and girls. If you're at home with your parent or your guardian, I want you to turn around and give them a high five. 5th graders, I'm absolutely proud of you. See you next time.